Hey there, welcome to dotnetFlix. Today we've got Jonathan Mezach here. Hi Jonathan.
Thank you.
We are going to talk about some very cool .NET Core tooling, right?
Yep, that's right.
Let's dive in.
And more specifically, diagnostics tooling. So with .NET Core 3.0, which is shipping in September, hopefully, we will get a new set of tools that we can use to diagnose our applications in production.
Cool.
And I've got a GitHub repository set up on my GitHub account, which includes all the things I'm going to show. So if anybody wants to follow along, they can go to my GitHub repo and have a look at it. So with that, I'm going to jump right in and show you what's going on.
If we talk about diagnostics, is that logging, monitoring, or also profiling and all that?
It's more like profiling like memory leaks and all that kind of stuff.
So really performance
diagnostics. Yeah, cool, definitely. So what I have here is I have this GitHub repository open in Visual Studio Code. I've got to put a README in there as well. So basically, I took a couple of samples from the diagnostics repo from the .NET team, and I put them in here, and I'm going to show you how that works. Now, one thing I want to quickly mention is that I don't have .NET Core 3.0 installed on my machine, but all the things I'm going to show you only work with .NET Core 3.0, so how did I do that? So one thing I did is I added this dev container, which is a development container that you can use with Visual Studio Code. And basically what's going to happen is that every bit thing is going to run inside of the container. So all my shells, all my editing and things are all running inside of the container, except that I have the UI on my host machine, basically.
Okay, and the container runs on your machine, on Docker desktop?
Yeah, it just runs on Docker for Mac, natively on my machine. So I have this dev container JSON file here, which points to the Docker file, which is on the left here. And it also says the extensions that I needed to install. I'll go into this in a little bit. And then the Docker file here is basically saying, okay, use the 3.0 preview 5 bits. I'm using the preview 5 bits here. There are newer bits, preview 6, but they didn't work, so I reverted back to preview 5. It's preview bits, right? And apart from that, it just installs a couple of useful tools, like you can do PS inside of the container, and there's Git in there. And I've also set up installation of the diagnostic tools that I'm going to show you. So there's basically 3 tools, .NET Counters, .NET Trace, and .NET Dump. And those are .NET Core global tools. So if you have the .NET SDK installed, you can go and do .NET tool install, --global .NET Counters. Now I have put a version in here because these are preview bits. Normally you wouldn't have to use the specific version, but
makes sense.
Cool. So this doc file, this dev container.json file, they are being checked into source control, right?
Yep.
So if I were to clone your project, I would have all the dependencies I need.
Yeah, basically. So when you open this project in Visual Studio Code and you have the remote development tools installed for Visual Studio Code, which is basically a set of extensions for Visual Studio Code, it will actually prompt you and say, there's a dev container here, do you want me to open it up inside of the dev container?
Cool.
And then it will build the container based on this Docker file, and then after that everything just works inside of the container.
Nice.
So yeah, that's really nice. Now the other thing I did briefly mention is this cap add sys-ptray thingy here. That's actually required because what we're going to do is we're going to connect one process to another process, and by default that's not allowed within Docker containers because of security and stuff like that. So that's why I added this, which basically allows me, otherwise I would get a permission denied basically. So this basically allows that. I think there is some guidance coming on how you would use these tools in an actual production environment, because maybe you don't want to set this flag, but
probably not.
Probably not. So yeah, there's a couple of caveats there, but basically this is what we need for now to make this work. Yeah. So with that, let's jump into the actual project that I have here. So this is just a regular ASP.NET Core web API project, nothing fancy here. So we have our program CS, which is just default. It's a startup CS, which is nothing fancy really. Of course, this is a targeting .NET Core 3.0 project, right? So that's important. And then the other thing is we have this values controller, which is just from the template. I didn't change anything here. This is just default. But the more interesting thing is this Diag scenario controller, which basically allows me to basically mimic a couple of interesting scenarios like memory leaks or CPU usage or stuff like that. So I can actually show you how these tools work. So nothing really special here, just a couple of samples. So what I'm going to do is I'm going to run this app on my inside of the container, right? So this is running inside of the container. It's going to start up the app, which is taking a little while. So now it's running, and it's running on port 5001 and 5000. Remember, this is running inside of the container. I can't actually access these port natively on my host, so I'll show you how we can work with that in a minute. And the other thing I'm going to do is I'm going to use this .NET counters tool. So if you've ever used performance counters on Windows, you're probably familiar with that. This is basically the same thing, except this is cross-platform.
Okay.
So I can use .NET counters. And .NET counters requires me to pass in a process ID. There's two things I can do. I can monitor an application, or I can list the names of the counters that I can basically watch or monitor. There's a small list right now. Previous 6 they expanded the list quite a bit. There's a lot of more counters you can actually look at. But for now we're just going to use the basic ones. So I need to have the process ID. Now, of course, I can use PS to list processes, but I want to specifically list .NET processes, and I can use .NET Trace to do that. So if you use .NET Trace and then list processes, it will list all the .NET processes that are running.
Nice.
And remember, this is only the .NET processes running inside of this container.
Yeah.
So let's copy the process ID here. This is my Diagnostics tooling web API project. And then do .NET counters, monitor. Then I need to put in the process ID with -p. And I need to pass in a refresh interval. So I need to tell basically how many times or how often I want to refresh the counters. So this is in seconds. I'm going to put in 1. And as you can see, it's now connected to my running process. It's showing me the CPU usage, which is 0 at the moment because it's not doing anything. It's showing me my working set, so the amount of memory I'm using, as well as the garbage collector heap size and Gen 0 collections, all that kind of stuff. So this is basically the basics. With previous 6, they've added things like requests per second and all that kind of stuff if it's an ASP.NET application. But so this list is expanding, but for now this is what we have.
Can you add your own custom counters to that list?
Yeah, you can. This is basically working on a thing called the event pipe, which was already introduced in .NET Core 2.2, but they didn't really do anything with it. Basically what happens, there's this Unix domain socket that you can connect to get the stuff that's coming through the pipe. And you can implement your own things and write to that pipe and then get out the stuff at the other end.
Nice.
So let's try to run the API. So let's actually trigger something in my application. And to do that, I'm using another extension that people might not have heard of, but it's called the REST client for Visual Studio Code extension. Basically what this allows me to do is write .http files where I can put in HTTP requests and I can send them straight from my editor. It's a bit like Postman, if you've ever used Postman, but on steroids, if you ask me. So, and I can put in documentation here as well. So this is really awesome stuff, and I can put in headers or anything you really want. So this is really powerful. So the first request I'm going to do is going to basically simulate a memory leak in my application. So it's going to memory leak a bit. So I'm going to send a request. As you can see on the left, it's coming in. And on the right, we can immediately see that our working set is basically going to 350 meg from 70, and it's not going down. So there's probably something leaking memory here, right? Yep. So let's try to figure out what's actually causing the memory to leak. So to do that, I'm going to quit the .NET counters. I'm going to use another command called .NET dump. And basically what that does, it takes a memory snapshot of my running process, dumps it out to a disk file, and then I can use that to analyze it.
Sure. Yeah.
So let's do .NET dump collect, and I can use the same process ID to get the dump from the process. It's going to take a little while because it needs to write all the memory out to a disk, so that takes time, obviously. But it should complete fairly easily. Now this dump file, I could take that to a Windows machine and open up in Visual Studio and see it there. Although there are still some things that aren't working quite well there yet, but that should work for your launches, I think. But we can also use .NET Dump itself to analyze the dump file natively on the machine that it's running on. So
Nice.
that makes it better. And of course, this always takes longer when you're doing demos, because that's what demos are for, but it's written in the dump file. So let's do .NET Dump Analyze and open up that core file, which is called, well, there's only one core file, so that's easy. And now I'm in my CLI or something. And if you've ever done WinDBG on Windows, this should be fairly familiar. It's the same experience, so it's the SOS tools that are available there to basically diagnose .NET applications. So one thing I can do is I can do a dump heap and say -stat, which basically gives me a statistic of all the objects that are in memory with their method table, which is basically the pointer to the type, and then the amount of instances that are in memory. And as you can see, there's a lot of strings, but well, strings aren't really that interesting. There's also a lot of customer class, which is probably some class from my application. So let's have a look at what these customer objects are keeping in memory. So if I copy this memory address and I say dump heap -empty, which basically tells me dump all the objects that have this method table, so basically all the objects of this type. And you can see there's a lot of them here. So we're not going to wait for that to complete, because that wouldn't be very interesting. But we also get the memory address of each of these objects. So let's just take one of those and say dump object. This basically shows me the object itself. So it shows me the name of the type and what method table it's using, which is the same address I had before, from what assembly the type is coming from. And it's also showing me all the fields that it's keeping in memory and the types of those. And it even shows me the memory address, which is this value here, memory address of that reference.
Okay.
So I can really see how things are related. Now, one thing you usually have in .NET applications, you have this garbage collector, which keeps references to objects. And once those references goes away, it will garbage collect and it will clean things up. But if there's a root object that's keeping something, there's a reference somewhere to an object, it will just keep it in memory because something is still referencing it. And we can then use the other command called gcroot, which basically, for a particular instance of an object, it basically shows me what the path is to the root of the garbage collector. So it can show me what's keeping that in memory. So let's use that. Now this takes a little while, and I've seen in demos that sometimes it doesn't complete at all. But at least it's completing now. So what we can see here is that this is the object that I just asked it to gcroot, and then it shows me this array with this memory address is keeping that object in memory, which is being kept in memory by this object, which is being kept in memory by this object.
So seems legit.
Yeah,
That's in cache. It's certainly in the cache.
Yeah, there's some cache going on here probably. So with this information, I can go back to my application, look at my code, and basically see what's going on.
Cool.
So yeah, this is really powerful stuff. If you have a production application that's leaking memory, this can really help you figure out what's going on if you can't figure it out from the code in an instant, right? So that's basically one scenario. That's basically an app that's leaking memory. The other interesting thing is an app that's running slow, right? So let's dive into the tools we have there. So I'm going to quit the .NET dump, and I'm going to do the .NET counter thing again. So .NET counters -p. It's the same. Well, I need to figure out the process ID.
73129.
You're really good at numbers, right? Yep, there it is. So I'm gonna do counters. I need to put in monitor as well. Refresh interval 1. So I'm gonna connect the counters again. Now I'm gonna trigger another request, which is taking a lot of CPU. So I'm gonna send a request. You can immediately see that if it's responding, the request is coming in.
It's not updating due to high CPU load.
Yeah, I guess so. That's interesting. Let's try that one more time. You can see it here. The CPU usage is 56%. It's using a lot of CPU. So something fishy is going on here. We can use the dotnetTrace command to actually create a dump of all the things that are running inside of my process to figure out where that CPU is coming from.
Nice.
So, but before I do, I'm gonna just quickly shut down my process here because I think it's using too much CPU right now, and it's basically hogging my machine. So let's start it over, and let's use dotnetTrace list processes again to figure out what the new process ID is, because it just changed. So that's the new one. So now I'm going to use dotnetTrace collect. Then I need to pass in the process ID again.
Yeah, sure.
And I need to, I can use the default format for this, which creates what's now called a netperf command.
Okay.
I think it's going to be renamed to nettrace, but and you can open up that in Visual Studio. But I don't have any Visual Studio here, so what do you do if you don't have Visual Studio? You can use another format called SpeedScope. So I'm going to pass in format, SpeedScope.
As you do.
As you do. And then that's going to start recording, and I'm going to send a request so we can actually see something happening. I'm just going to let it run for a little bit. Then I can just press enter to exit the trace collection. And then it's writing to this trace.speedscope.json file, which is, again, takes some time. And now I can take this SpeedScope JSON file and load it up into a program called SpeedScope. And that's basically a browser application. So I'm going to switch over to my browser and switch over to SpeedScope, which is at speedscope.app.
Oh.
And I can use the browse button here to go to this SpeedScope JSON file here and open it up. And it's going to take a little while. And then it's going to basically show me what's called a flame graph. And if you've ever done Chrome developer tools, you're probably familiar with this because it uses the same format if you've ever done a profile there. And I can see the different threads here. And so let's switch to one that's actually interesting, like this one. So we can actually see all the things that are going on, all the things that are taking CPU.
Wow.
And we can zoom in a little bit, so we can actually see what's taking the time here.
That's pretty cool.
And all the way through the stack, basically. So basically this is measuring how much CPU is being spent in each method, and then that's going to show you.
So the SpeedScope file, it doesn't contain any of your data, right? Like variables or memory dumps, stuff like that, because you've just uploaded it to a external website.
No, it's only showing you signatures of methods basically, and the amount of time it takes, but it's not dumping it's not like the memory dump we did before, right? So it's not going to show you your data and upload that. You don't want that. So and there's a couple of views I can use here. So I can use left heavy, which basically shows the thing that's taking the most time on the left side. It's not really easy to read. You really need to dive in to really understand what's going on.
But there's a lot of information in here.
So
you need to be able to read this.
Yeah, you should be able to figure out what's taking CPU time here. And there's this sandwich view as well, which basically allows me to take one of these, and then it's going to show me what's calling me, and what is this thing calling, and then what takes the most time here. So if you've ever done any profiling, this should be fairly familiar. But you can also use things like .trace by JetBrains. It can open up these files as well, at least in the latest preview versions. So there's a lot of tools you can use to actually dive in and figure out what's going on.
Cool.
So and with that, that's basically it.
Nice. Yeah, I think this is very handy if you're troubleshooting your application. So of course we should write code that doesn't have any problems in there, but once you have one, you need this kind of tools to do this. And also I think it's very cool that you can just point it to a production application. Yeah. So
there are some caveats with going to permissions and stuff like that. So there will be some guidance on how to actually do this with a production app.
Nice.
Like one thing I'm still trying to figure out, if you want to install .NET core global tools, you need to have the SDK installed. You can do that with just the runtime, even though it will run on the runtime. So I'm not sure how that's going to work out, but yeah, there's still some things to figure out. But yeah, I think it already shows a lot of promise for the future, and it definitely helps with teams that are like developing on Windows, but running their production applications in containers on Linux. And that's going to really help them.
Cool stuff. Yeah. Thanks for showing us.
No worries.
I hope you guys liked it also, and we'd like to see you in the next episode of dotnetFlix. Later.
Bye.